Welcome back, everybody, to another great episode of the Golden Knowledge Podcast. I'm your host, Pat Voss, here live on YouTube. We have, I'm so glad that you guys came to the premiere. Thank you so much for coming. And I will be chatting with you in the side as well when you ask your questions about this interview here. So I have a great interview guest for you today. Science is my first love. You guys all know that. My guest today is former NASA Deputy Chief Technologist and Deputy Director of Planetary Science, Jim Adams. Jim, how are you?
I'm great, Pat. It's a pleasure to be here.
The first question I have to start off with, because for myself being in broadcasting almost 17 years now, I know that you did a little bit of broadcasting in college. What got you interested in that? What kind of hobby was that for you?
So, when I was in college, broadcasting was very different than it is today. There was nothing digital about it at all. And what interested me was how you take a sound that goes into a microphone and it goes into a wire and then it goes into a mixing board and then it goes out to an amplifier and up to an antenna and then you hear it, right? And so I got into radio mostly because of the technical side of it. I was a physics major in college, and we can come back to that. But that kind of allowed me to use my gaining knowledge of physics with something practical, which was in radio. It turned out that if you wanted to be part of the radio station, you also had to take some airtime. And so I did a 70s rock music program on Saturday mornings. It was just like every other radio station in the United States at the time. And, we took requests and we did the news and all that sort of thing. And then when I got out of college, I didn't do it anymore. I really wasn't involved in radio. I did do a little sound mixing from time to time over the course of my career, but just last year, in fact, so nearly 40 years after I got out of college, actually a little more than 40 years, I got invited to do a monthly radio segment on a radio station in South Africa. And we can also talk about South Africa if you want. And so for the last year, every first Sunday of the month, I do a radio segment on stars and planets in South Africa. The good news is they let me do it in English because I don't speak a word of Afrikaans, but the community still seems to like it.
So I wondered, while we touch on that for a minute, what did you want to, if you want to circle back around to South Africa, we can, but I would say for right now, everybody's wondering, and I've heard this from a lot of people on my Twitter feed and DMing me all over social media. How did you land a job at NASA? How did you do that? Because I'm even curious, and I'm sure that my listeners and viewers are curious as well.
So that's a bit of a journey. And in order to tell the whole story, you have to go back to college and physics. I was in a small liberal arts physics curriculum, got a BS in physics from a small liberal arts university in Western Pennsylvania. And when I was there, I had this electronics lab. Well, in that day, they were mostly teaching analog electronics. Digital was just becoming useful. And so I got excited about the idea of using digital electronics to do things. And I had created a little circuit that would track a satellite, use two antenna rotors and track a ham radio satellite as it flew over, and a few other things, operate some lab equipment and that sort of thing. And I thought to myself, well, this is kind of going to be the future. And I looked around me, and down the road was this company that made cash registers. And back then, if you remember, maybe you don't, cash registers were these clunky things that looked a little bit like a typewriter. You pushed a button and up would pop a leaf with the number on it, and it would add everything up for you, and you hit total, and the drawer would open, and the cashier would make change for you, from their memory, right? And now today, those things are all digital, just like I was thinking, just same vision. And in fact, we don't even have cash registers anymore. Nowadays, you just wave your credit card at a point of sale terminal, and it just all happens automatically. And well, it turns out the cash register company had the same vision too. They knew that their machines were going to go digital, and so I went and I interviewed for a job, and they were polite, and then I got back this nice letter that said, "We're very sorry, but we're not hiring physicists. We're looking for electronics and electrical engineers." So I had made the first mistake in my career was misjudging what the skill set was necessary in order to accomplish the vision. So I ended up having to go with my second choice, which was aerospace. And I ended up working at General Electric in Philadelphia and Valley Forge, Pennsylvania, on civilian satellites, commercial satellites, military hardware, that sort of thing. And that's where I really cut my teeth. Now, you wanted to know how I got to NASA. One day I was assigned to work on the International Space Station. Back then we called it Space Station Freedom, and we were doing the design of it. And I had a briefing to a customer who was NASA. After which, I was having coffee with them, and they said, you really should be working here. You should really be working for NASA. And I said, well, let's talk about that, because at the time, GE had bought RCA, and they were combining divisions, and they weren't really sure if the Valley Forge site was going to stay open and whether or not we'd all have to leave or do something else. So it turns out they made me an offer I couldn't refuse, and I took the job working on Space Station Freedom at Goddard Space Flight Center. So pretty much overnight, I became my boss's customer. And that's how it started. That's how I got into NASA. Something I had done as a subcontractor had attracted the interest of the customer, and the customer said, "We really want you here." And that's how it happened. I didn't have to go through a long, arduous interview process. I was actually very blessed by that. Yeah, it was a pretty seamless process. It doesn't happen that way for most people, though. Yeah.
How long did you work for NASA?
28 and a half years or something like that. Yeah. 10 years at General Electric, call it 29 at NASA. And then I started consulting as soon as I got out of NASA. And so in fact, yesterday I was at a meeting working on a topic for NASA. So even though officially I've retired, my wife points out that I haven't really stopped working.
I'm wondering, a lot of people don't know background, of your family and how there's also a connection there. And your father has a connection to the Apollo program. Can you let us know what that is?
Yeah. So my father grew up in the Great Depression, and he was the first member of his family to graduate from college. Went to the University of Alabama and got a civil engineering degree. And I believe that it was World War II, maybe, yeah, World War II, that he got an exemption from going into the military if he would work on government interest, on things that were in the government interest. And so he took a job designing rockets and at Rocketdyne, and actually went out to the San Andreas Fault. There's a test range out there, and blew up some rocket motors and had to go around picking up the pieces to try and figure out what went wrong and that sort of thing. And then ultimately he came east, and we were living in Virginia at the time. He was working for a small subcontractor that doesn't exist anymore, and they had this contract with Grumman in Bethpage, and they needed a mechanical engineer or somebody with at least knowledge of stress to work on the structural stress models for the lunar excursion module, the LEM, for the Apollo program. And so he got that job. And I remember as a child, this was before the landings, obviously, so mid 60s. I remember him coming home very concerned because of the design margins that were on that unit. He would say that the walls of the LEM were made out of aluminum foil. Well, you can go today and look at the lunar excursion module in the Smithsonian, the prototype, and it wasn't exactly aluminum foil, but he was, maybe using a little hyperbole, but he was very concerned about it. And so when in 1969, when Aldrin and Armstrong landed, he was very concerned, and of course we were all sitting up watching it, and that was sort of my introduction to the space program, was through my father and his this task he had been given to do the stress analysis on, or to be part of the team that did the stress analysis on the LEM.
I'm wondering, speaking of your father being part of that team and yourself being part of many teams throughout your work with NASA and GE, I'm wondering, what are some of the best technologies that you've been able to work with over the years? Just kind of run us through a few of them, and the floor is yours.
Yeah, so in terms of developing technologies, the things that we're going to look towards the future, I would say the work that we did on laser communications, and still are continuing, the agency is still continuing to do on laser communications. Laser communications is an exciting technology because it has the potential of raising the amount of data that we transfer from far destinations to extreme levels. And so we actually flew a mission called Laddie to the moon and demonstrated that we could do laser communications at I believe it was 650 megabytes, which by terrestrial standards seems slow, because these days we want gigabyte bandwidth on our phones even, right? But all the way from the moon, that's a pretty big deal. And so hoping that technology now will get refined, and it'll be as commonplace as putting a radio on board the spacecraft. And so that's one. The other technologies, to single out a single technology is kind of maybe difficult, but to talk about how when NASA goes to solve a problem, a big problem, like keeping astronauts alive in space kind of problem, or pointing the Hubble Space Telescope to the deepest parts of our universe, those solutions have applications directly here on Earth. And that's what everybody calls a spin-off. So NASA develops a pointing algorithm for the Hubble Space Telescope that does sort of triangulation on stars and groups of stars, and then triangulates on those. And in that way, then the Hubble knows exactly where it's pointing, or the scientists operating Hubble know exactly where it's pointing. And well, it turns out that the marine biologists were trying to figure out how to track and catalog whale sharks. Now, whale sharks are these enormous, gentle beasts. They're 30 meters long, some of them. And they have very dark skin and these white spots all over their dark skin that looks like a star field. So, marine biologist and one of the folks that was working on the Hubble were having coffee one day at a conference, and they put their heads together and they said, well, gee, I wonder if we could use the Hubble pointing algorithm to identify a whale shark. And do you know it worked? So the dots on a whale shark are like a fingerprint. The Hubble algorithm treats the dots like a star, like stars, and now they can identify the animal without having to tag it or even get near it. You just need a picture of it, and they can identify which animal it is. So that's kind of cool. Another technology which is kind of neat is NASA developed a protein, or isolated a protein called DHA, I think it is. And they found it because they were looking for ways to assure that the astronauts on the space station and space shuttle were getting the right nutrients. And so they isolated this actually from seaweed. And years later, a fella picked up the license to utilize that technology, and he was able to create a nutrient supplement that was at one point in time in half of the baby formula around the world. So in some ways you could say NASA was feeding the world.
See, I like that. One technology that I was actually asked by a fan of my show, one thing that I was asked to ask you about is the James Webb Telescope that is going to be launching.
Oh yeah, what a fantastic machine that is.
Can you go into at least a little bit of detail as to what they're using this telescope for and why that matters?
Oh, so yeah. So the details of the James Webb Space Telescope. I mean, there's a dozen different new technologies on James Webb. Foldable mirrors and mirrors that you can change the deformation of, and the fact that there's a very cold section like liquid nitrogen temperatures that's isolated from the rest of the spacecraft, and then there's this sunshade the size of a tennis court that keeps the sun from shining on the telescope itself, so that we can measure in the infrared the radiation that is now was visible at the start of the beginning of the universe about 300 million years after the Big Bang, and is now redshifted down into the infrared. So when the Hubble Space Telescope looks deep into space, it's going to be actually looking back in time. Some astronomers actually call telescopes time machines, because you're seeing the light that was emitted at the time it was emitted, and then of course the further it's traveled, the more time it's taken to get to you, so you're actually looking at the history of the source of that radiation. Well, there's this region of time postulated by the cosmologists just after the Big Bang, well, 300 million years after the Big Bang, called, oh goodness, I've forgotten the name of it. It's like the reionization period, and it's the time when hydrogen was created. And so one of the most fantastic things will be the opportunity to look at what the universe looked like at first light. And I think it's going to be historic. It's going to change the way we look at ourselves inside the universe. It's going to change the way we look at the universe itself. It's going to change textbooks all around the world when the science data starts coming back. And of course, it won't be just one image. It'll be years of data taking, and then scientists chewing on it and debating and looking at theories and that sort of thing. But I think it's gonna be like Hubble was, but times 10. It's just going to be fantastic, and I'm really looking forward to the launch and the commissioning of the James Webb. It's going to be great.
So that kind of leads me, before we get to final question here, I'm wondering, what are you most excited about, including, obviously you just said about the James Webb, but what are you most excited about the future of space exploration, or the space program, really?
Yeah. So when I started at NASA, I had to take a training class. it was in a kind of a boring topic called government contracting. But one of the most important things I learned at NASA, I learned in that class, which was the government should be doing what the private industry can't or won't. And and so that's why NASA exists. And that's why oftentimes you'll see things like, well, why is NASA buying rides to the International Space Station from SpaceX and building Artemis at the same time? You know, or why do we have some NASA field centers building satellites, but we also go to Lockheed Martin and Boeing and all those other companies to buy satellites? And it's because there's this mix of of NASA trying to lead the way, lead the direction, also trying to stay technically sharp. But the intent of the space program is to stimulate the U.S. economy and the global economy, as well as expand our knowledge and the knowledge base about who we are and where we're going. So the thing that I find just terribly exciting right now in this day is the coming together, the finally it looks like commercial space enterprise is happening. And it, it wouldn't have happened if it hadn't been for NASA. It's fantastic that it's happening without NASA now, but the technologies necessary, the rocket technologies, the computer technologies, the communications technologies, the understanding of how you build a spacecraft, all of that was developed through the US space program and is available to the US citizens to apply in a commercial enterprise. And so for me, the idea that in several years, or maybe even a decade, there'll be private space stations that you can visit on a holiday, or private research center in orbit that you can take your latest um, chemical experiments to in order and utilize the benefit of microgravity for the research. That's just fantastic. The government doesn't have to get in the way of it. The government has had a hand in developing the possibility of it. And now the interest seems high. Space tourism, interest in space tourism is up. Um, and the number of commercial entities out there doing space exploration is fantastic. And what does that do? That enables NASA to move on and do the other things now that private industry can't or won't. And some of that is send humans to Mars. People say, well, are you competing with Elon Musk? Well, maybe a little bit, but that's okay. The bottom line is NASA's interest in going to Mars, to the moon, and then to Mars will keep private industry on track. They'll keep the same vision alive, and I think that's a great use for us as a government to stimulate the growth of a new industry.
And now finally, the final question. And I heard you use this, and I spoke to the person who helped us set this up. And the question is, how do you want to be remembered?
Oh, I want to be remembered as someone who cared. This all of this doesn't matter if people get hurt or if people get left behind, if we don't capitalize on the potential of the diverseness of the human population. And so for me, what's extremely important is that we help the next generation realize its potential. And the human potential is deep. The things that we can do are mind-boggling. Some of the things that we will do, we haven't even thought of yet. And I just think it's fantastic to be alive in this day and age and to be able to care about what's going to happen in the future. And so that's I guess that's my answer to your question.
I appreciate that. Folks, Thank you so much for sticking around for this amazing interview today on the Golden Knowledge Podcast. I'm your host, Pat Voss. You can find me on all social media at Golden K Pod, Golden K Pod. My guest today has been former NASA Deputy Chief Technologist and Deputy Director of Planetary Science, Jim Adams. Jim, thank you so much for coming on today.
It was my pleasure.
All right, guys, I will see you in the next episode.